Hello there, and welcome to the Sleepless Scientist, where curiosity curls up under a blanket, and even the most powerful forces of nature can be explored with wonder and calm. Tonight's journey might sound a little intense at first, but don't worry, it's all wrapped in softness, science, and imagination. We're traveling beneath the surface of the earth, to the deep, molten heart of a sleeping giant, a supervolcano. But this isn't a story of fear. It's one of curiosity, of dreaming big, and of wondering what it would mean if we ever tried to stop one from erupting. So before we dive into the molten depths of our gentle thought experiment, I'd love to know, what time is it for you right now? And where in the world are you listening from? I'm always amazed by how many people from all corners of the globe gather here, not to panic or rush, but to rest, to wonder, and to dream together. If you find comfort in this kind of sleepy science, I'd be truly grateful if you tap the like button, or maybe subscribe to this cozy corner of the internet. It helps our quiet explorations reach others who might be lying awake, looking for something thoughtful, something slow, something shared. So now settle in. Let the day fall away behind you. Let your thoughts drift, light as ash on the breeze. Because even in the face of something as mighty as a supervolcano, there's room for softness, for story, and for scientific awe. Somewhere between geology and imagination, pressure and possibility, lies a gentle question. What if we tried to stop a supervolcano eruption? Let's begin. Take a slow, deep breath. Inhale and exhale any lingering tension. As your breathing steadies, imagine that we are drifting high above the earth on a clear night. Below us, dark silhouettes of mountains and valleys stretch out to the horizon. Among them is a broad, serene landscape, perhaps a grassy plain or a tranquil lake, that hides a powerful secret beneath. We are about to descend into a world beneath the surface, where ancient fires slumber quietly. Along the way, we'll learn about supervolcanoes, what they are, where they lie dreaming, and what makes them so powerful, all in gentle, simple terms. We'll imagine what would happen if one of these giants were to wake, and then we'll explore the central question. What if humanity tried to soothe that awakening giant, to stop a supervolcano eruption before it could happen? Throughout this journey, you remain safe and relaxed, an observer floating gently through time and space. There will be no sudden shocks or loud alarms here, only wonder and understanding. Even the mightiest volcano is part of nature's grand story, and we will view it with a calm, curious gaze. By the end of our journey, what first might sound like a frightening scenario, a supervolcano poised to erupt, will become an intriguing, almost lulling tale. So let your eyes grow heavy and your mind drift with ease. The sleepy scientist will be your guide, speaking in a soft rhythm. Let's begin our exploration together, stepping quietly into the dark beneath the earth and into the heart of a sleeping supervolcano. Imagine now that we gently descend from the night sky, down toward that tranquil landscape below. The air is cool and still. We come to rest in a vast meadow at dusk. All around us, crickets sing a slow lullaby, and a gentle breeze whispers through tall grasses. In the distance, a few low hills and ridges are silhouetted against the stars. One of those broad, unassuming hills is actually the rim of an enormous hidden crater. You might not notice anything unusual at first glance, perhaps a quiet lake, a cluster of trees, a bison herd grazing without a care. But beneath our feet, deep in the Earth's crust, lies a supervolcano, a sleeping giant, patiently biding its time. What is a supervolcano? In the stillness of this night, let's explore that idea. Picture a normal volcano, perhaps a classic cone-shaped mountain like Mount Fuji or Mount St. Helens. a towering peak with lava and ash that can burst forth from its summit. Now imagine something much larger, but paradoxically harder to see. A supervolcano doesn't always form a steep mountain. Instead, it often appears as a broad depression or caldera, a giant sunken bowl created long ago by an unimaginable eruption. Supervolcanoes are defined by the vast scale of their eruptions. When they erupt at their fullest fury, they can eject at least 1,000 times more volcanic material than a typical volcano. In fact, one of the ancient eruptions here at Yellowstone, one of the world's best-known supervolcano sites, spewed out about 2,450 cubic kilometers of ash and rock, enough to fill entire valleys and cover continents. It was so massive that scientists bestowed the term supervolcano upon it. As we walk slowly through the moonlit meadow, we realize we're actually inside one of these enormous craters, though it's so large that it just feels like gently rolling land. This is the Yellowstone caldera, formed by a super eruption about 631,000 years ago. Yellowstone is not the only giant of its kind. There are around 20 known supervolcanoes on Earth, scattered across the world. Each one is like a sleeping dragon beneath the ground. Some rest under tranquil lakes, such as Lake Toba in Indonesia, which hides the site of a colossal eruption 74,000 years ago. Others under peaceful plains, like Yellowstone in Wyoming, or under lush forests and mountains. These giants are rare and patient. Major supervolcano eruptions happen on average only about once every 100,000 years. In between those rare cataclysms, the supervolcano sleeps, often for tens of thousands of years, while life carries on at the surface as if nothing were amiss. Beneath us, the sleeping giant is not completely still. It's more like a creature in slumber that occasionally stirs or sighs. Far under the ground, a vast pool of magma, molten rock, is collected in a chamber within Earth's crust. This magma chamber is the beating heart of the supervolcano. It's miles wide and reaches depths of several kilometers. At this moment, most of that magma in Yellowstone is not fully liquid. It's a thick, hot mush of mostly solidified minerals, with melted rock interspersed, like a thick stew quietly simmering. Scientists using seismic waves to peer inside have found that Yellowstone's magma chamber is currently only about 5 to 15% molten, which means it's too solidified to erupt on a huge scale right now. That should comfort us. The giant is fast asleep, not poised to wake anytime soon. We might notice subtle signs of the heat beneath us. In Yellowstone, the sleeping volcano gives itself away through geysers and hot springs, spectacular fountains and pools of hot water that owe their existence to the magma below. Every few minutes or hours, the famous Old Faithful geyser shoots up a spray of hot water and steam into the night air. These geothermal wonders are like the calm breathing of the volcano. They show that heat is flowing upward, but in a gentle, controlled way. In fact, without the magma's heat, these geysers and bubbling springs would cool and go silent. The land here has been volcanically active for millions of years, and even between super eruptions, there are occasional smaller eruptions or lava flows that act as relief valves. Since that last gigantic eruption long ago, Yellowstone has experienced dozens of smaller eruptions, at least 80 of them, including lava flows that oozed out and partially filled the caldera, as well as a few more explosive events. The most recent volcanic eruption here was a slow lava flow about 70,000 years ago, which is recent in geologic time, but so very distant from human history. These smaller eruptions are the volcano's way of letting off steam naturally, preventing pressure from building too quickly. Much like a safety valve on a pressure cooker, small eruptions and frequent hot spring activity can gradually release heat and pressure, helping keep the giant at rest. As we continue our quiet stroll, we reflect on how peaceful the surface of a supervolcano can appear, while extraordinary forces lie dormant beneath. The ground we walk on was once part of a tremendous explosion, but now it's covered in wildflowers that have closed their petals for the night. Perhaps a distant owl calls, and a gentle plume of steam from a hot spring drifts in the moonlight, carrying the faint scent of minerals. It's a reminder that even the most fearsome natural powers can have periods of calm that last millennia, and in those long stretches of peace, ecosystems thrive above. Elk, bison, and bears roam Yellowstone's valleys. Forests and rivers adorn the caldera's rim. Life is not only possible here, it is flourishing on the back of the sleeping giant. Take comfort in this stillness. The timescales of supervolcanoes are immensely long, far longer than a human lifetime. Yellowstone's last supereruption was over 600 millennia ago, and it might be hundreds of thousands more years before another of that magnitude happens, if it ever does. Statistically, scientists estimate the chance of a massive Yellowstone eruption in any given year is extremely low, on the order of fractions of a percent, or even less. In fact, Yellowstone is not overdue for anything. It does not follow a strict schedule, and if the average gap between huge eruptions is roughly 700,000 years, that means our 631,000-year gap so far is not particularly alarming. We likely have many generations of time to simply enjoy the beauty of this place. So as you stand here in the dark meadow, feel the solid earth beneath you and know that at this moment, all is calm. The giant slumbers, and we are safe in its realm, listening to the gentle bubbling of its hot springs and the quiet rustle of the night. Now imagine in this dreamy exploration that we can gently drift back in time to witness what a supervolcano eruption might look like, not to frighten ourselves, but to understand it with awe and respect. We remain merely observers, like spirits watching from a safe distance, as one of these giants begins to stir. The scene is ancient and otherworldly. We might be hovering over what is now Yellowstone, but the landscape below is as it was hundreds of thousands of years ago, before modern humans ever walked these lands. At first, we feel a deep rumbling underfoot, so deep that it's more sensed than heard, like a distant thunder resonating through the ground. This is the magma chamber, far below, starting to press upward. Over thousands of years, heat rising from Earth's mantle has been melting rock, accumulating a great reservoir of magma. As molten rock collects, it also releases volcanic gases, water vapor, carbon dioxide, sulfur dioxide, which dissolve into the magma like fizz in a soda. The pressure builds ever so slowly. The land subtly swells. The ground arches upward, as if a giant is taking a long, slow breath beneath a thick blanket. Perhaps cracks begin to appear in the land, encircling an area many miles across. These are not sudden or jarring at first. They are gradual fractures forming around the edges of the bulging dome of rock above the magma chamber. Now the moment of awakening draws near. When the pressure from below becomes too great, the crust can no longer contain it. All at once, perhaps triggered by a final influx of hot magma or an earthquake, the ground rips open along those cracks. In an instant, geologically speaking, the dissolved gases in the magma are released. It's as if a colossal pressure cooker has vented its steam, or a shaken bottle of champagne has popped open. The gases expand explosively, blasting the magma out with them. What happens next is truly extraordinary. A super eruption begins. We watch in silent astonishment as a towering plume of ash and fire rises where there was once a peaceful plain. It's as though a column of storm clouds made of ash has sprung from the earth, reaching tens of kilometers into the sky. The plume is lit from within by lightning, the friction of ash particles generating sparks, making it flicker with an eerie glow against the darkened daytime sky. Close to the eruption site, the scene is unavoidably destructive. Molten rock, lava, and shattered pieces of old solid rock, ash and pumice, are blasted out at high speed. Anyone unfortunate enough to stand within a few dozen miles would see the sky turn black as night in moments. But remember, we are safe observers in this scenario, floating at a gentle remove, taking in the science of it without panic. From our vantage, we can see that the eruption isn't just a vertical column. Heavier ash and pyroclastic flows, fast-moving currents of hot gas and ash, are pouring across the ground in all directions, glowing dimly like rivers of lava-coloured fog. These flows can race across the land at hundreds of miles per hour, flattening everything in their path with intense heat. In a supervolcano eruption, such flows can extend tens of miles outward, covering a region the size of a large metropolitan area in a thick, hot carpet of volcanic material. The immediate surroundings of the volcano, say within a 100-mile radius, are devastated and buried. In our imaginary scenario, vast swathes of what we know as Wyoming, Idaho, and Montana begin to vanish under layers of ash. The cloud rising into the stratosphere carries finer ash particles high into the jet stream. Soon, ash begins to fall from the sky like snow in areas far away. Within hours, a powdery grey ash may drift down on distant cities and forests. The western half of North America is blanketed by ash from this single day's nightmare. Even a few hundred kilometers away from the eruption, the ash might accumulate to about 1/3 of a meter, roughly a foot, thick on the ground. Farther away, perhaps 1,000 miles or more, a thinner dusting of ash still settles, a few centimeters thick, but enough to disrupt modern life if it were to happen today. The entire continent feels the touch of the volcano's breath. High above, the finest ash and sulfur gases spread around the planet on stratospheric winds. The sky, even far from the eruption, takes on a hazy veil. Sunsets and sunrises turn strangely vivid, with brilliant reds and oranges, as sunlight filters through the microscopic ash and aerosol droplets. But beneath the beauty lies a climate shift. Sunlight is dimmed by this global haze, and the Earth begins to cool. We recall a more recent event. In 1991, a much smaller volcano, Mt. Pinatubo in the Philippines, erupted and lofted sulfur dioxide gas high into the atmosphere, which formed reflective droplets. The result was a measurable cooling of the Earth's surface by about 0.7 degrees Celsius, 1.3 degrees Fahrenheit, for a few years. Yet Pinatubo was tiny compared to Yellowstone's hypothetical super eruption. Pinatubo's eruption was roughly 1,000 times less voluminous than Yellowstone's largest past eruption. If a supervolcano pours out that much more ash and gas, the climate effects could be profound. It could be like a volcanic winter, a chill that lasts for years, in which crops struggle to grow and the weather patterns shift unpredictably. Our dreamlike journey shows us glimpses of the aftermath. Close your eyes and imagine the landscape a day after the eruption has ceased. The great roar has quieted to an uncanny silence. A thick grey blanket covers everything in sight. The shapes of trees and buildings, if any were there, are softened under piles of ash. The air is still and carries a biting smell of sulfur, like spent fireworks and struck matches. If we wander through a nearby forest, we find the trees have been scorched and knocked down by the force of the blast. Farther out, where the ashfall was gentler, the weight of ash has collapsed roofs and made roads impassable. Rivers run thick and slurry-like with ash washed from hillsides. It is as if a part of the world has been powdered and hushed. Such an eruption would indeed be devastating. In the immediate vicinity, most living things would perish in an instant. It has been estimated, in scenarios by some scientists, that if Yellowstone were to have a massive eruption like this, The direct casualties in the first hours might number in the tens of thousands or more, essentially anyone too close to escape. That sounds dire, but remember, this scenario is exceedingly rare, and it is not fated to occur in our lifetimes. And even if such a cataclysm did happen, it would not be the end of humanity or life on Earth, not by far. Our ancestors have been through at least one supervolcano event. The Toba eruption in Indonesia, 74,000 years ago, was a colossal blast, possibly the largest in the last few million years. Scientists think it covered the entire Indian subcontinent, thousands of miles away from Toba, in about 5 centimeters of ash. Imagine the entirety of India blanketed in ash, 2 inches deep. Evidence suggests it caused a global volcanic winter, a severe cooling that may have lasted years. Some researchers once hypothesized that Toba's eruption nearly drove humans to extinction, possibly reducing the human population to only a few thousand survivors, a concept called a genetic population bottleneck. This theory is debated, but it paints a picture of how powerful the eruption might have been. And yet, humanity survived. Those few thousand became the many billions of us alive today. Life, incredibly, went on. In the thick of a volcanic aftermath, even as famine or colder climates might have tested our species, humans found refuges and persisted. Elsewhere, other life forms also survived. Animals, plants, the seeds in the soil, the fish in the oceans. Over the following decades and centuries, the climate recovered as the skies cleared. Forests regrew in the ash-enriched soils. New ecosystems emerged on the fresh volcanic land. Volcanoes destroy, but they also create. The minerals in volcanic ash break down into fertile soil, nurturing abundant plant growth in later years. The caldera left behind can become a crater lake, like Lake Toba today, a serene blue lake ringed by forested mountains, born directly from the eruption's fury. In time, what was ground zero of devastation can transform into a place of tranquil beauty. Hold this thought gently. Even the most intense natural disasters are part of Earth's long story, and life has a remarkable resilience. Earth's history is filled with upheavals, supervolcanoes, asteroid impacts, ice ages. And yet here we are, listening to the night sounds and pondering these events from the safety of our beds. It gives us a sense of perspective across deep time. A supervolcano eruption is immense on a human scale. But on the time scale of the planet, it's a dramatic chapter that eventually gives way to renewal. Now, our journey through the ancient eruption draws to a close. The ash has settled, and we drift upward again from the ashen plain, back toward the present. We have seen what could happen in a worst-case scenario. A rare but monumental eruption that alters the world's face for a while. As we float above the quiet caldera of present-day Yellowstone once more, under a peaceful starry sky, we feel a sense of awe. It's comforting to know that such events are extremely infrequent, and that today's Yellowstone shows no signs of an impending super-eruption. The giant remains fast asleep. But our curiosity isn't satisfied yet. Now we turn to the heart of our thought experiment. What if humans, with all our ingenuity and creativity, tried to prevent such a catastrophe? Could we ever truly tame the forces beneath our feet? Let's explore that question as our journey continues. We now arrive at the crux of our gentle exploration. Imagine yourself, still in the calm night, contemplating the mighty power of a supervolcano and the potential devastation of an eruption. It's only natural to wonder, must we remain at nature's mercy, or could we do something to intervene? Humans are problem solvers and dreamers. In our waking world, engineers and scientists have long imagined heroic interventions to protect us from natural disasters, from diverting asteroids to controlling hurricanes. So what about a supervolcano eruption? What ideas have people proposed, and could any of them work? In the stillness, we close our eyes and envision a small circle of scientists gathered around a table. Perhaps it's late evening in a research laboratory, the room lit by the soft glow of lamps, cups of coffee, gone cold, and pages of sketches and calculations are spread out as they discuss bold plans. We listen in quietly. They speak of drilling, of cooling, of vents and valves, of ways to soothe the volcano or release its fury in a gentler way. Their voices are calm and thoughtful, tinged with both hope and caution. We realize that we are hearing echoes of real proposals that have been floated in recent years, proposals to prevent a supervolcano eruption or at least diminish its threat. One scientist, let's call her Dr. Green, unfolds a map of Yellowstone. She traces a line around the edges of the volcano's vast magma chamber. What if we could cool it down? She asks softly. The idea she describes is ambitious but surprisingly concrete. In 2017, engineers from NASA actually proposed a plan to drill into the flanks of the Yellowstone supervolcano and pump down water, using the volcano's own heat to generate power while gradually cooling the magma. Dr. Green explains in a measured voice. We would carefully drill several holes outside the park's fragile geyser fields, reaching toward the magma reservoir. Then, we'd pump down cold water at high pressure. The water would absorb heat from the hot rock and magma, and we'd pump it back up to the surface as steam or superhot water at about 350 degrees Celsius, 662 degrees Fahrenheit. This heated water could then drive turbines to generate electricity. Imagine a geothermal power plant running off the volcano's heat. In our mind's eye, we picture this as giving the volcano a cooling bath. Bit by bit, year by year, the water draws off the heat that makes the magma dangerous. The scientists estimate that if they could lower the temperature of the magma chamber by perhaps 30 to 35%, it might solidify enough that an eruption becomes far less likely. Essentially, they aim to stabilize the magma, to lull the giant back into a deeper sleep. As fantastic as this sounds, it's not pure fantasy. NASA experts did outline this concept, putting a price tag of about $3.5 billion on it. It's a large sum, but in the realm of a national infrastructure, not impossible. They argued that perhaps private geothermal energy companies could foot some of the cost, since the plan could generate a lot of electricity over decades. After all, Yellowstone is effectively leaking a tremendous amount of heat continuously, on the order of 6 gigawatts, which is like several large power plants worth of heat. Tapping into that could power entire cities and, as a side benefit, gradually cool the volcano's heart. In our relaxed, dreamy state, we imagine drilling rigs quietly humming on the outskirts of the park, pipes circulating water into the depths, and clean electricity lighting up homes. All while the magma slowly, imperceptibly cools over many years. It's a vision of turning a threat into a boon. The sleeping giant becomes a gentle giant, providing warmth and light instead of destruction. But as in all good stories, there is a note of caution. Dr. Green's colleague, Dr. Brown, interjects with a gentle frown. Drilling into a volcano is not without risk, he says. He reminds the group, and us listening, that they must be exceedingly careful. Puncturing the pressurized layers around a magma chamber could be like poking a balloon. If done recklessly, it might even trigger the very event we seek to prevent. Indeed, the US Geological Survey has weighed in on such ideas. In a calm, factual tone, the USGS has pointed out that drilling into hot, semi-molten rock is extraordinarily difficult and expensive, and even if you succeed, any hole would quickly seal itself as minerals, in the superhot fluids crystallize, clogging it up. It's like trying to insert a needle into tar. The tar might just gum it up. Moreover, removing heat or pressure too quickly can backfire. Volcano experts note that a sudden drop in pressure can actually drive magma to erupt, since dissolved gases will come out of solution and expand. It's somewhat counterintuitive, but imagine you have a bottle of champagne. If you pop the cork suddenly, the pressure release causes the champagne to froth out explosively. Similarly, drilling a well into a magma pocket to let the pressure out might instead cause a violent degassing, effectively uncorking the volcano. Dr. Brown quotes a USGS statement softly. Attempts at cooling and depressurizing magma systems would have many unintended negative consequences, including making an eruption more likely. Everyone around the table grows quiet for a moment, acknowledging the weight of those words. Furthermore, we think of the unique wonders at Yellowstone, the geysers and hot springs we visited earlier. Those depend on the volcano's heat. If we siphon off too much heat or fluid, Old Faithful and other geysers might fade or disappear. The very act of trying to tame the volcano could spoil the beauty and natural heritage of the place. Yellowstone is also a protected national park. Laws currently forbid geothermal energy development in the area because tapping that heat even a little can dry up the springs. In our mind's journey, we imagine a scenario. What if by saving Yellowstone from an eruption, we unintentionally killed Yellowstone's living geothermal features? It would be a bit like saving a patient, but losing their most unique quality of life. This doesn't necessarily kill the idea of intervention, but it reminds us that any action has consequences. The scientists in our story weigh these trade-offs. Perhaps drilling could be done outside the park boundaries, angled inwards deep below so as not to directly disturb the surface hydrothermal systems. It's a complex puzzle, and they know they must solve it delicately, if at all. Now another voice pipes up in our imaginary late-night meeting. Dr. Silver, an engineer with a flair for the dramatic. Cooling is one approach, she muses, but what if we relieve the pressure, like letting steam out of a kettle gradually? We imagine an eyebrow raised around the table. The idea of venting the volcano comes with serious challenges, but let's explore it in this safe, hypothetical space. One might conceive of drilling not just to extract heat, but to actually open pathways for gases to escape slowly, or even to cause small controlled eruptions that are much less destructive than a giant one. Perhaps, Dr. Silver suggests, a network of boreholes could intersect the top of the magma chamber or the volatile rich zones, allowing volcanic gases to bleed off before they accumulate to explosive levels. In theory, this could depressurize the system gradually, analogous to carefully lifting the lid of a pot to let out steam. However, as we recall, the USGS expert already warned that depressurization is a prime driver of eruptions. We're reminded of that champagne bottle analogy. Letting a little gas out might instead cause a foaming rush. To attempt something like this, one would have to be extremely sure that the magma would not flash into explosive activity. Perhaps it would only be feasible if the magma was already near the point of erupting, but at that stage, any interference could just as easily trigger the eruption. It's a risky tightrope to walk. Our mind drifts to an even more dramatic notion. Could we intentionally trigger a very small eruption at the surface to forestall a larger one? This sounds a bit like causing a controlled avalanche to prevent a bigger one later, or setting a small fire break to stop a wildfire. In the case of volcanoes, humans have actually experimented with influencing eruptions, albeit on a tiny scale. In 1935, when Mauna Loa in Hawaii threatened a town with its lava, the US Army Air Corps bombed the lava flow to try to divert it, with limited success. And in 1973, on the Icelandic island of Heimaey, citizens faced a lava flow advancing on their harbour. In a heroic effort, they sprayed the lava with seawater to cool and solidify it, eventually saving the harbour by slowing the flow. That actually worked, a real-world example of humans taming a volcanic threat on a small scale. The lava cooled into a wall, sparing the port, and later, the Icelanders even used the residual heat for warmth. These stories encourage Dr. Silver. "We've diverted lava before," she says, "though a supervolcano is a completely different beast. Diverting a lava flow is not the same as stopping an explosion of ash." Perhaps, she muses, if a supervolcano were showing signs of an impending eruption, swarms of earthquakes, rapid ground deformation, intense gas emissions, one could do something like drill a conduit and cause a smaller eruption in a safe direction, like lancing a boil to release pressure. But the feasibility of that is deeply questionable. If the magma is very gas-rich rhyolite, like at Yellowstone, any eruption, even a small one, could quickly grow out of control. And drilling down to the magma in time is a slow process. It might take months or years to bore a hole, and predicting exactly when or where to drill is another huge uncertainty. As our imaginary council of scientists debates late into the night, a consensus emerges that direct intervention is fraught with peril. The volcano is like a giant living system that we barely understand. Poking and prodding, it could have unintended consequences. Geoengineering a supervolcano, as such grand intervention might be called, remains a very speculative concept. That said, the group is not completely discouraged. They also discuss indirect strategies, which we now envision in our mind's theatre. One strategy is to focus not on stopping the eruption, but on mitigating its effects. This is a form of geoengineering in response to a volcano, rather than to prevent it. For example, if a supervolcano eruption is inevitable or already underway, could we do something to protect the climate and agriculture? Some have suggested stockpiling food reserves in advance, or even developing artificial lights for greenhouses to keep crops growing during years of dim sunlight. Those are adaptation strategies rather than prevention, but they're part of the human toolkit for survival. Others have whimsically imagined giant filters or barriers that could be deployed in the atmosphere to capture ash or reflect less sunlight, though at the scale of a supervolcano, such things currently belong more to science fiction than reality. We might picture fleets of high-flying drones seeding the volcanic cloud with substances that cause ash to clump and fall out more quickly, shortening the volcanic winter. It's a fanciful idea, but perhaps someday our technology could manage something along those lines. Another intriguing possibility: if we had many years or decades of warning that a super eruption was building, which, to be fair, we likely would, given how magma accumulates, humanity might respond by altering our global behaviour to offset the cooling. Imagine we knew that in 50 years, a supervolcano would dim the sun for a decade. In theory, we might intentionally warm the climate slightly beforehand, for instance, by temporarily reducing aerosol pollution or even adding greenhouse gases, so that when the eruption occurs, the cooling effect starts from a warmer baseline. This sounds risky and would be controversial, effectively tinkering with Earth's thermostat in the opposite direction that we currently worry about. It underscores how delicate balancing climate is. But thinking in a dreamy way, the goal would be to prevent a devastating deep freeze and global famine by any means necessary. As we float through these scenarios, we realize something. Trying to stop a supervolcano requires operating on timescales and scales that dwarf anything humanity has ever done. It's a bit humbling. We have built great dams, tunneled through mountains, even sent people to the moon. But controlling the Earth's inner heat is still beyond our reach. The amount of energy in a supervolcanic eruption is staggering. We recall an interesting comparison. The energy released by the 1883 Krakatoa eruption, a much smaller event than a supervolcano, was equivalent to a certain number of nuclear bombs per second. A supervolcano would be orders of magnitude more. The forces at play are so titanic that to truly neutralize them, we would need technology and resources on an almost science fiction level. The risks of meddling with a sleeping giant. Let's step back from the conference table of scientists now. We find ourselves again in the quiet night outside, wandering along a moonlit path near the edge of a tranquil caldera. We've heard the bold ideas and the sober warnings. What have we learned? It seems that while humans can conceive of interventions, cooling the magma, venting the pressure, diverting flows, each approach carries significant risks and unknowns. Think of the supervolcano as an enormous pressure-filled vessel. Altering it is not like fixing a small machine with known parts. It's more like negotiating with nature itself. One risk repeatedly brought up is that any drilling or disturbance could trigger the eruption prematurely instead of preventing it. That would be the ultimate tragic irony. In trying to stop a disaster, we cause it to happen sooner. This has happened in smaller contexts. For instance, mismanaged oil drilling or fracking has caused unintended small earthquakes by releasing pressure underground. Those are tiny compared to what a magma chamber holds. So there is a profound humility required. Another risk is environmental damage. Even if no eruption is triggered, we might spoil the precious surface features, geysers, hot springs, unique microbial life in those boiling pools, by altering the underground heat plumbing. We might also cause earthquakes. Drilling into hot rock and pumping fluids can induce seismicity. In a worst case, imagine a scenario where a well collapses and water suddenly flashes to steam underground. It could create a violent explosion in the borehole, a localized eruption in a place we didn't intend. There are also geopolitical and ethical dimensions. Yellowstone and other supervolcanoes are often in protected lands or remote areas. Who decides to undertake such an intervention? Would the people living on that land agree to the risk? And if a project went wrong, who would bear responsibility? Our gentle story doesn't want to stray too far into politics, but it's something to ponder. Perhaps in some future, nations of the world might come together to supervise such a project for the common good. It would truly be an Earth-scale endeavour. We also realise that fundamentally, our scientific understanding of supervolcanoes is still incomplete. Yellowstone has been extensively studied, and yet mysteries remain. How exactly does magma accumulate? What signals reliably precede an eruption? Could there be a slow release event that is not catastrophic? For example, not all volcanic activity is explosive. Sometimes magma can simply intrude and cool without an eruption, or only lava flows out without much ash. The Yellowstone area might more likely experience a small lava eruption or a powerful hydrothermal blast, like a giant geyser explosion, than a super eruption, at least in the foreseeable future. Our efforts might be better spent preparing for those more likely scenarios, which are dangerous on a local scale, but not global. As we wander, we recall one optimistic thought from the NASA plan. Even if preventing an eruption is extremely difficult, the act of using the volcano's heat for energy could be a win-win on a different front. It's said that harnessing geothermal energy from supervolcanoes could supply power for tens of thousands of years. By tapping that energy, we also reduce reliance on fossil fuels, potentially helping mitigate climate change, humanity's more immediate challenge. In this indirect way, a supervolcano's pent-up heat might actually protect life, not by stopping an eruption, but by giving us clean energy and reducing other environmental risks. It's a beautiful irony to consider. The giant's heat, if carefully managed, could keep our homes warm and our factories running without polluting the air, all while slowly taking the pressure off the volcano. It's a very long-term strategy, a kind of geothermal guardianship where over centuries we continually milk the heat out and keep the system stable. Is it practical now? Perhaps not with today's technology, but it's a vision to guide future innovation. So, in summary, what have our musings revealed? Yes, humanity has dreamed of stopping a supervolcano, with ideas ranging from the pragmatic, geothermal cooling, to the fanciful, artificial vents or protective shields. Each idea comes with formidable technical hurdles and potential unintended consequences. At this moment in history, we likely could not execute any of these plans with confidence. The safest course, most experts agree, is to carefully monitor these volcanoes, which we do. Yellowstone has a sophisticated monitoring system scanning its every tremble and temperature change, and to develop robust disaster preparedness plans. If there were signs of an eruption years or decades in advance, our efforts might go towards civil defense, evacuation strategies, stockpiling food, and perhaps trying smaller-scale mitigation like strengthening roofs against ash, or developing cloud seeding techniques to precipitate ash out of the atmosphere sooner. Those measures, while not as spectacular as stopping an eruption, could save many lives and help society endure the event. Now our journey is nearing its end. We find ourselves once more drifting gently above the quiet caldera of a supervolcano in the present day. The night is almost gone. A hint of pre-dawn grey light touches the eastern sky. The giant beneath remains asleep, as it has for millennia. As we hover in this calm early light, let's reflect on what we have seen and felt. We travelled into the Earth's depths to understand what a supervolcano is, not a monster to be feared irrationally, but a natural feature of our planet, operating on a timescale so vast that our everyday worries seem tiny in comparison. We painted a picture of what an eruption might be, but we did so in order to replace fear with knowledge. By seeing it play out in our imagination, we came to appreciate both the power of such events and the resilience of life that follows. We learned that while a supervolcano eruption would undoubtedly be a dark and challenging time for humanity, it's not an apocalyptic end-of-the-world scenario. It's a challenge that our species could survive, as we likely have before. We also explored the creative lengths to which human ingenuity might go in attempting to assert control over natural forces. There is something poetic about that effort. Tiny creatures, humans, daring to tamper with the engines of the earth. It speaks to both our courage and perhaps our hubris. In our dreamy narrative, the scientists were thoughtful and cautious, aware of their limitations. And indeed, the conclusion was that the forces of a supervolcano remain beyond our direct control, at least for now. Perhaps one day, far in the future, if technology and knowledge advance tremendously, people might actually be able to perform feats like cooling a magma chamber or preventing an eruption reliably. Imagine future generations, tens of thousands of years hence, treating volcanoes with advanced tools as casually as we treat wildfires with controlled burns. We cannot rule out what clever solutions may emerge over long spans of time. But there is also a gentle wisdom in recognizing the limits of human control. Our story is a lullaby of understanding that we share with you. It is okay that we can't command volcanoes. The Earth is an ancient, dynamic being, and we are recent guests on its surface. Rather than conquering every aspect of nature, we often find peace and safety through respect, preparation, and adaptation. We have early warning systems for volcanoes now, and international cooperation to study them. We strive to reduce other stresses, like climate change or resource depletion, so that if a natural disaster strikes, we are strong and united in our response. In a way, that is how we stop a supervolcano, not by literally preventing its eruption, but by preventing it from destroying what we cherish, by being ready and resilient. As the first golden rays of sunrise peek over the horizon, gilding the clouds with gentle light, We take comfort in the beauty and continuity of the world. The dawn brings reassurance. The supervolcano sleeps on, and may do so for many thousands of mornings to come. But even if one day it should rouse, we have the gift of knowledge passed down through generations. We know what signs to watch for, and we have learned from the past. Just as importantly, we have the capacity for wonder and cooperation. If faced with the rumblings of a waking giant, humanity would not be helpless. We would bring all our science, compassion, and ingenuity to bear, doing our best to protect life. Some of the ideas might sound like science fiction, cooling the Earth's crust or guiding eruptions. But every great human achievement was once a fanciful dream. For now, though, as you lie comfortably and think about these grand ideas, you can feel a sense of awe without anxiety. The earth beneath us might occasionally remind us of her power, but tonight, she is quiet. The truly colossal events are, thankfully, exceedingly rare. And each day that passes without such an event is a day we can be grateful for the benign environment we mostly enjoy. The ground under our feet provides food, support, and home. Even volcanoes, when dormant, create wondrous landscapes and fertile soils that nurture life. In the final, gentle moments of our journey, we hover above a scene in the far future, purely imaginative, yet comforting. The Yellowstone caldera is quiet, as it has been, but dotted here and there we see small facilities. Perhaps geothermal plants sipping heat from the earth in a balanced way, managed by careful hands. Scientists and park rangers work side by side, ensuring that geysers still dance and steam vents still sing, even as some heat is harnessed for humanity's use. Children in that future time learn about the great supervolcano under their home, but they do not fear it. They grow up understanding it, knowing its rhythms, its history, and how their ancestors left them a legacy of knowledge and tools to live in harmony with it. We have no way of knowing if that vision will come true, but it's a serene thought. Humans and supervolcano coexisting in a kind of equilibrium, respectful and prepared. The key is understanding, the very thing we have been cultivating in this bedtime exploration. As you prepare to drift into sleep, let a few final images dance in your mind like fading stars. The immense magma chamber glowing softly like a hearth in the depths of the earth. The gentle puffs of geyser steam under a moonlit sky. The dedicated scientists with mud on their boots and hope in their hearts, listening to the heartbeat of the volcano through their instruments. And the endless stretch of time during which the earth remakes herself, over and over, long after our lifetimes. We are part of this grand story, but we are not its authors, and that is okay. Rest easy with the knowledge that while we may not be able to stop a supervolcano today, we can study it, appreciate it, and find comfort in the understanding that comes from science and imagination hand in hand. The Earth's deep forces, once terrifying unknowns, become almost friendly in the light of comprehension, like wild storms observed safely from a shelter, or like a great ocean that we navigate with our trusty ship. We conclude our tale with a sense of reverence for nature and its scale, and a sense of gratitude for human curiosity that seeks answers even in the face of the sublime. The sky is growing lighter now. Dawn is here. Our dreamy journey comes to a close. The supervolcano sleeps on peacefully, and so can you, cradled by a planet that, for all its occasional fury, sustains us day after day. Understanding replaces fear, and knowledge itself is a kind of gentle power. With that thought, let your mind drift and your eyes grow heavy, knowing that the world remains a place of wonder by day and night. Sleep well, dear traveller, and remember, even the mightiest volcano is but a part of Earth's eternal lullaby, sometimes loud, mostly quiet, and always a fascinating melody if we listen with curiosity and care. Good night.